All right, ladies and gentlemen, week and a half into this corona shutdown that might last the whole year. It sounds like it might. Probably miss my pretty face. Can't get to see that right now. Maybe just a little bit there. Yep, that's good. But you can hear my beautiful voice. So there's a PDF of this on Schoology. Print it off or just do your work on a separate sheet and then submit that on Schoology. I'm going to talk through how to do these problems. Try to do them on your own first and then come back and revisit this video for quick explanation for how to do them. So I'm going to shut up for 10 seconds. Okay, I can't shut up for 10 seconds, but try these on your own and come back and see if you did them. So one of the things you should be using is checking sample size, and that's that MP has to be greater than or equal to 10, and then the other one is the N times 1 minus P has to be greater than or equal to 10. Let's just make sure the sample size is big enough that you get a large enough standard error for the study to work. So if you did that, you're basically just dividing 10 by 0.28 using this sample proportion for P. N is the number of people you're trying to solve for that you need. It should have been in around 35.7, which you can't have 35.7 people. So you got to round that up to 36. Sorry. Hopefully you got that one right. And this is a warm-up I would have given in class. So this is exactly what we would have done in class if we were doing this, follow-up to what we did the last lesson. Hopefully you read in the book. Hopefully this feels a little like it's in class here with me talking in your ear. You can shut me up at any time. You can replay my voice. It's much easier to get me to repeat myself on this video than it is in class. Part B would be if you had sample size of 200. And you wanted to find standard error on here, what would this thing look like? And hopefully these come up on here. So you got to find your center and your center of your proportion. Now you don't have to believe in that number right there. That would be 0.72. I think I did this on StatKey on my own. And that's what it gave me. You shouldn't have to use StatKey on this at all. If you use that formula for standard error, you should get around 0.03 for standard error, which would give you 2 points left and right of that. Pardon my sketch on here. It looks much better on a smartboard than it does on here. 0.654 and 782, sorry. And this looks like it's a 95% confidence interval to use that, to get that value. So this formula we're talking about with confidence intervals, hopefully you started to use where you have your sample statistic plus or minus the z-star value times the standard error, times that standard error that I calculated, which is another new formula. George had sent me an email asking me where the heck this z-star value comes. I think it was George. Somebody asked me, maybe Nolan asked me that question, which is a good question. The z-star values come from your notes from chapter 5. So this is directly connected to what you did in unit 5. So there's a z-star value for 95%, there's one for 98%, there's one for 99%, there's one for 80%. I think we had a table with all those, which will come up again in a few minutes here. Actually, I think I can find it, depending on how smart I am. Oh, take it back. Maybe it'll come up later on, though. So whenever you're constructing the actual confidence interval, you got to know the confidence level. So we're going 90% on this one. You got to use that big square root thing with a bunch of calculations in there. Now the sample, and this is question 3 that we're now on, the sample was 0.45. You multiply that by 0.55. I call that its complement. You divide that by the sample size. So there's 50 people in the sample. And don't forget to take the square root at the end, otherwise you get a number that makes no sense at all. So the standard error is going to be pretty small. And again, the reason these are small is because these are percentages. This is like a 7% standard error. You're never going to get something that's like 1.25 when you're talking about proportions, because this number can't be above 100%. So it's usually going to be a fairly small standard error for single proportions. So that number gets plugged into your formula. Your z-star value, again, comes from your table. And your sample statistic was the one that was given on there. So if you look that up in the table, and you could get this from StatKey, but hopefully you don't have to use that anymore. The small table we had in Unit 5 so it gives you 1.645 for a 90% confidence interval. multiply those two, a little order of operations, which we love from Math 1, multiply, and then add or subtract just like you did way back in the beginning of the year. And we are 90% confident that P, the population value, is between 0.334 and 0.566. Hopefully that made sense. There's the work from last year that I did on number 4. Hopefully you can see it in red. It looks like you can't see this part very well. This is just showing distribution curve and what happens when you're between 0 and 1. Centered at 0.5 would give you the maximum highest possible value for standard error. It's 0.011. And you might wonder, where the heck does this come from? Well, if you think about it, if you're multiplying these two fractions, these two decimals by each other, if one of these gets really big or one of these gets really small, you're not going to get a very big standard error. So if the sample statistic was 0.5, that's the best you could possibly get. It's just kind of a question about analyzing that formula, kind of messing around with the formula. And then down here in question 5, it looks like you probably can't see it. I'll move this over here so that even Asher can see that. That 98% confidence interval is 2.327 approximately. And then a 95%, of course 95% we know is 1.96 from that table. And I'll show you that table one time real quick here. This is the notes I would do if I was in class with you. But down here at the bottom, that's all the stuff you already know. Down here at the bottom is that specific table. It's a copy. It's a copy and paste from Unit 5. So that's the table that Nolan was asking about there. And that's where that 98% confidence interval comes from, 2.326. There's your 95% confidence interval value. Hopefully those make sense, guys. Try those out. Submit the work on Schoology, and then there's a homework assignment that goes with this too that we do in class with 4 problems. Hopefully they work out for you.